together, chef's kiss beautifully. All right, so let's talk about free energy. So what are we going to do with all this free as an available energy? If we let the universe have its way, it all comes out to a homogeneous gray blob at about 4 degrees Kelvin. This is called the heat death of the universe. And that, honestly, is pretty boring, right? Things that are homogeneously the same are not really interesting. So that was Thanos may have been inevitable, but he was inevitably wrong, right? You could actually go through and, with your knowledge of kinetics, realize why cutting the population in half would only have bought him about a couple of decades, right? Because what are you going to do? What's your T1 half going to be for populations, right? We can extract the energy and do useful things with systems that are not at equilibrium, and we call that work, which, to be honest, can be pretty boring too, right? So here in our hydroelectric dam, we've got water with high gravitational potential energy up top, lower gravitational potential energy at the bottom, and as the water goes over, we extract that work to spin turbines and generate electricity. We will see in the next chapter that we can have chemical potential energies giving us useful work. So, the maximum amount of useful work obtainable from a process at a constant temperature and pressure is equal to the change in free energy. So work is equal to delta G max. Under certain conditions, delta G for a spontaneous process represents the available energy that is free to do useful work. For a process that is not spontaneous, the value of delta G tells us the amount of work that we must expend to make that process occur, right? Could we take some water from down here and pump it back up to the top? Indeed you can, right? But is it going to cost you some energy? Indeed it will. How much? Well, how much energy would you get from going from the top to the bottom? Right? It's the same amount. And in fact, there are places that do that, where they will take hydroelectric power and they will run the dam during the day to generate electricity, and then at night, when electric rates are cheaper, they will pump the water back up. And so they're using this dam as basically a physical battery to store energy. The amount of work obtained from a spontaneous process is always less than the maximum possible amount, right? Because the Entropie der Welt strebt einem Maximum zu, right? The universe is always going to take a cut. Achieving the maximum work available from a spontaneous process can occur only via a hypothetical pathway. Right? We're never going to go completely towards completion. Any real pathway is always going to waste energy. If you're an engineer, right, you are going to come to hate noise and vibration, right, which is sound, or it could be heat, right? You're going to start to hate noise, vibration, and heat. If you're an engineer, maybe not right now, but when you get to that 3rd, 4th year, they're going to become a constant pain in your side. So in a real cyclic process in a system, work is changed into heat in the surroundings, and the entropy of the universe increases. A reversible process with the universe, the systems, and the surroundings is exactly the same as it was before a cyclic process. And that never really happens. You can get things that are pretty darn reversible, but never 100%. An irreversible process, the universe is different after the cyclic process is performed. And all real processes are, to some degree, irreversible. After any real cyclic process is carried out in a system, the surroundings have less ability to do work and contain more thermal energy. Things get hot as you do work. Right? So look at the work done by a battery. A battery can do work by sending current to a starter motor, right? Start your car. And it can be recharged by forcing current through it in the opposite direction. So your internal combustion engine, is going to drive the alternator, which is then going to force the battery to recharge. If the current flow in both processes is infinitesimally small, W1 is equal to W2. It's a reversible process. But if the current flow is finite, as it would be in any real case, W2 is always going to have to be bigger than W1, which is an irreversible process. The universe is different after the cyclic process has occurred. So let's do another concept check. You got 2.4 moles of a gas, and it's contained in a 4-liter bulb at a constant temperature of 32 degrees C. It's connected to a valve and evacuated. Assuming the temperature is constant, can we calculate delta H E, Q, and W for that process. Okay, it is going to be, they're all equal to 0. Since it's a constant temperature process, delta H is 0, and delta E will be 0. The gas is working against 0 pressure. It's an evacuated bulb, so our PDV work, right? Ordinarily, you'd have some P delta V work, but because your pressure is 0, that W term is 0. So W plus Q is going to be 0. So delta H is 0, E is 0, Q is 0, and W is all 0. We see thermodynamics in living systems. So, for example, C6H12O6 oxidation, our glucose oxidation, you're going to get minus 2,288 kilojoules per mole. And going from ADP to ATP is going to cost you 31 kilojoules per mole. Right? So in the synthesis of proteins, the first step, we're going to take like an alanine and a glycine to form alanine glycine. The delta G is going to be positive 28 kilojoules per mole. So is it by itself spontaneous? No. By itself, it's not spontaneous. That's why we need enzymes to help find those lower energy conformations. That's why we're going to need to expend energy coming from our ATP going backwards to form ADP. So we're going to power this by making this. Right? So we're going to get some coupled reactions. The ATP plus water plus alanine and glycine is going to give us ADP and H3PO4 and alanyl glycine. And so our overall free energy change is going to be minus 31 plus 29, and it's going to give us minus 2 kilojoules per mole. So our protein synthesis is now favored because we're coupling in energy from somewhere else. Right? So our non-spontaneous process is being powered by that other reaction. And that's what you see in this ATP cycle, right? You got some ADP, it's going to get converted into ATP, adenosine diphosphate and adenosine triphosphate for my non-bio people. And then that ADP is going to convert back down to ADP. There's going to be some free energy associated with that, which lets you take your amino acids from a lower energy state and build them into proteins at a higher energy state. Right? So going from glucose and bringing it back down to CO2 and H2O, that metabolic process has an energy change associated with it, which takes our ADP and brings it up. Our ADP is able to then give energy into those amino acids, which then move it up to the proteins. The end.